All right. So far, all the work we have done with graphs is to do with the linear functions. So everything that we have done in chapter 4, they're linear functions. And linear functions are those functions that give us straight line graphs where the highest power of x is 1. It has a gradient on a straight path. Now, what we haven't looked at are those types of graphs which give us curves or which give us fluctuations, the gradients increase and decrease. And what we will be looking at now is all of those other graphs which are not linear, so the non-linear graphs. Remember when we had done quadratic equations when we were doing expanding and factorizing, and they were in the form of like two brackets. We had two brackets, and they were in the form of you had questions like expand, something like this. So expand x plus 3 into x plus 4. Remember that? Now, who remembers how to expand? When we expand, what do we do with each of the terms in the brackets, x and 3 and x and 4? Try doing that. I won't do that for you. Try doing that. Try expanding. And we end up with something which looks like x squared plus 5x plus 6. Now see how the highest power over there is 2? Okay, now these types of equations are quadratic equations, and the graphs that they give us is called a parabola, which is that word. Okay, and the curve that we get is in the shape of this, like a U or smiley face. Let's say smiley face. These are our smiley face graphs. Okay, now the basic equation for this graph is y equals x squared, which is that. Okay, now when we get y equals x squared plus 5x plus 6, or y equals x squared plus x minus 6, and lots of different variations, it doesn't mean that it's not a parabola. We still have the x squared. So the highest power of the x is 2, which tells us that it's a quadratic function, and therefore the graph that we should be expecting should be looking like this. Okay, so we do know that, but the plus 5x and plus 6, they give us different transformations of the graph, which means that it could be moving up or moving to the right or moving to the left, a range of things, which we don't have to worry about right now. Okay, so the general form is that. That's the general form. That one is just the basic form. If there's no constants, and basically the A, the B, and the C are where you'll see numbers. So that's where you have constants. Okay, they are constants. It could be any number. So when the graph is y equals x squared, so if the coefficient of x squared is a positive number, then we have a smiley face like this. Okay, so if it's a positive number, so y equals x squared graph, this will give us a smiley face curve. If y equals negative x squared, what do you think that would be? Negative. Opposite of smiley face? Sad face, exactly. So it's upside down U. Okay, so that's the first thing that you need to identify. That if it is a positive y equals x squared, if it's positive, then you have a smiley face. If it's y equals negative x squared, then you have a sad face. Okay, now there are few parts of the graph that we need to identify. Some of the main things are, now the parabola is symmetrical about a line called the axis of symmetry. So what that means is that if we draw this line, and if we have a look, okay, what do we know about symmetry? Symmetry is something that is symmetrical, means you see the mirror image of that on the opposite side. So if you have a look at the positive x squared graph, if we draw a line right in the middle, okay, a vertical line right in the middle, imagine that that's a piece of paper and we've got a vertical line and we fold this in, it'll map exactly onto each other. So therefore this line, this vertical line, is called the axis of symmetry. And if you have a look at the y equals negative x squared graph, same thing. Axis of symmetry. So our x squared graphs, or our y equals x squared graphs, or these parabolas have an axis of symmetry which is vertical. So if it's vertical, if you have a look at this curve over there, if it's vertical, that means it's crossing the x-axis because it's a vertical line. So therefore this line will always have an equation of x equals something. Make sense? Okay. Now, the key points that we need to know about our curves, our smiley face curves, or more mathematical term is the parabolas. That's one of the first things, our axis of symmetry. Okay, it's always a vertical line and it will always have an equation of x equals something. So the first thing is, okay, our axis of symmetry will always have x equals a number. A stands for number. All right. Now then, there's something called the turning point or the vertex. Okay, that's another important word, the vertex or the turning point. Obviously, turning point, the word turning point gives us an indication what it means. That means it's the place where the curve changes direction. So if you have a look at the positive curve, it is, if we start the curve over there and it starts to go down, but at that point onwards it starts to move up. Likewise for the negative x squared graph, if you go from left to right, it's increasing, and then from that point onwards it starts to decrease. So the turning point or the vertex is basically the place where the curve starts to change its direction. For a positive x squared graph, for a positive parabolic graph, the turning point is at a minimum. Minimum, you can relate it that it's at the bottom, because if you have a look at these two, that turning point is at a higher scale on the y-axis compared to that turning point. So a positive y squared graph has a minimum turning point. A negative y squared graph has a maximum turning point. So that's another piece of information that's good to know. Okay, so y equals x squared will have a minimum vertex, and y equals negative x squared will have a maximum vertex. Okay, now if moving on, if these curves will be drawn on a grid, which is you'll be having the x and y axis, and it's a graph, so there's a very high chance that it'll be intercepting our y-axis, which is the y-intercept, and it'll be intercepting our x-axis, which are the x-intercepts. Now, take note that it is the x-intercepts, plural. Okay, now what that means is that it has two x-intercepts. And it makes sense if you think that there's a line of symmetry, which means it's a mirror image. So if this curve crosses at the x-intercept of 1, 0, and it's one place away from our vertical axis of symmetry, then one place away it'll cross the x-axis again. So in that sense, it makes sense. Now, all the time that's not the case. Sometimes you have three variations of these graphs. Now another one, and I'm just going to draw them. That's x and that's y. Sometimes you have graphs like that. So hanging above the x-axis, no intercepts. Okay? And then sometimes you have just one x-intercept. So just 1 point. Now, obviously, this is demonstrated in the equation as well. But again, we don't need to worry about that too much now. for now you need to know that they will have y-intercepts and they will have x-intercepts. Okay, so it has y-intercept and x-intercepts. So those are just identifying those things. Now let's do an example to see if we are able to identify these important points. Now have a look at this graph. Okay, for the following graph state the equation of the axis of symmetry, the type of turning point, whether it's maximum or minimum, the coordinates of the turning point, the x-intercept and the y-intercept. Alright, so let's start from the beginning. The equation of the axis of symmetry. Now, I think that if I have an axis of symmetry, actually has to be dotted line. Okay, if you have a look, axis of symmetry goes through the turning point. So the easiest way to do that is to find the turning point first, which is there. And our axis of symmetry will go right across. What point does it cross? -3. And as we said before, our axis of symmetry, because it's a vertical line, it's always in the form of x equals something. So it crosses at -3, therefore x equals -3 is our axis of symmetry. Okay, the second one. What type of turning point is it? Is it a maximum or minimum? It's a negative graph, so therefore the turning point is right on top. So it has a maximum turning point. It has a maximum turning point at the point over there. Let's read the coordinates of that point. The x coordinate is -3, the y coordinate is 5, so therefore it has a coordinate of -3, 5. So we've done the first three. The x-intercept. So let's look at this. Two x-intercepts. One over there and one over there. Let's see, it's a different color. Okay, 2 points. So one of them is at negative, so x-intercepts. One of them is at -5, 0. The other one is at -1, 0. And the y-intercept, the place where it cuts the y-axis, is over here. So therefore our y-intercept is at 0, -5. Good? Okay. I think that's pretty straightforward. Now, let's try plotting one. So now we have an equation. So we've got an equation as y equals x squared minus 1. Let's try to plot it. And once we plot it, then let's identify our features of the turning point, the axis of symmetry, and things like that. Okay, so to plot, all we need to do is just substitute in the equation. So y equals x squared minus 1. For -2, it'll be y equals -2 squared minus 1, which is -2 squared is 4 minus 1 is 3. So that is 3. For the second one, 1 minus 1 is 0. For the third one, it's -1. For 1, it's 0 again. And for 2 is 3 again. Now, if you have a look, that table itself gives us our axis of symmetry. So if you have a look at the table, from that point onwards, to the left and to the right, it maps. Okay, so that tells us itself what the axis of symmetry would be. Alright, so let's draw them. What I'm going to do is I'm going to let you draw that. So let us draw. Oh no. Let's draw this very quickly. Okay, so if we plot this, -2, 3, -1, 0, which is over there, and then 0, -1, which is over here, and 1, 0, and 2, 3. And if we draw the curve, we get something like that. Okay, whoopsie. Okay, now I need to get rid of